All right, in this video, we're going to talk about the difference between vectors and scalars. So let's first define what a vector is and what a scalar is. So the definition for a scalar that the books give can be seen here, and it is that it's a physical quantity that has magnitude but no direction. Some good examples of scalar quantities would be speed, time, and mass. These all involve numbers where the direction of the number is not important. For example, it wouldn't make sense to say your mass was 100 kilograms east. A vector quantity, however, the direction is important. So examples of vector quantities would be displacement. You moved 7 meters east or 5 blocks north. Velocity, I had a eastward velocity of 8 meters per second, or even the unit of force. If I push on a box, it's important to know which direction I'm pushing. In physics, the way we represent a vector is with an arrow. And so, for example, if we were looking at the velocity of these two players, I would say the red player has a greater velocity than the blue player because his arrow is longer. He has a greater magnitude. And the arrow also gives us direction. We can see this player is heading in this direction, and the blue player is heading in this direction. It leads me, the way I'm going to define the vectors is I'm going to say, what's the MUD of a vector? MUD stands for magnitude, unit, and direction. So for example, if we were looking at the red player, we could say that his magnitude would be 5 meters. Whoops. His magnitude would be 5. His unit would be meters per second. And his direction, I'm going to say, is 5 degrees south of east. So I'm going to talk about this direction here for a second with a vector. How do I know 5 degrees south of east? Let's say, for example, that we had this vector, which is of this length. So the magnitude we could measure with a ruler, or I could just give it to you. So I'll tell you the magnitude of this is 7. And it's a velocity. So the magnitude would be 7. The unit would be meters per second. And the direction. So how does the direction work? Well, if I look at this, I see this vector is heading in the northeast direction. But northeast isn't specific enough because a vector heading in this direction could be northeast, or a vector heading in this direction could be northeast. But this particular vector is heading in that direction. Well, I have an angle here, and I know the angle is 35 degrees. So I can use that to get my direction part of my vector very, very accurately. If I know this angle is 35 degrees, I then know the vector is 35 degrees north of the east quadrant. So we see here's the east, the line for east, and this vector is north of that. It's raised above that by 35 degrees. So one way I could write this direction would be 35 degrees north of east. N of E is physics shorthand. That's fine. But some of you might say, well, wait, Mr. Held, I think there's another way I could say the direction. If you think about this angle, you are also correct. We know, based on our understanding of geometry, that this is a 90-degree angle. So if this angle is 35, this angle here must be 55, right? So this is a 55-degree angle. You could also use the blue angle to record the direction of this vector. What you could say is it's a 7 meter per second vector at a direction of 55 degrees. Now here's the north, and the vector is east of that. It's towards the east line by 55 degrees. So you could also say this direction down here as 55 degrees east of north. Okay? So that's how we deal with direction in physics when we're dealing with vectors. Okay, so the way I would show, back to the soccer player and his vector, the way I would show his velocity is with the letter V for velocity. We'll do it in black. And from now on, when we write vector quantities, we're going to put an arrow above the symbol for any quantity that is a vector. So I would say his velocity is 5 meters per second, 5 degrees south of east. Right? So this would be how we would write his velocity vector, 5 meters per second, 5 degrees south of east. So we have magnitude, unit, and direction. So let's practice writing magnitude, unit, and direction for these 4 vectors. So just so you can read my writing in case you're having trouble, here's a 50-meter velocity vector, and this angle is 50 degrees. Here's a 3 meter per second acceleration vector heading in this direction, and this angle is 31 degrees. Here's a 5 meter displacement vector, and this angle is 14 degrees. And here's an 80 meter per second velocity vector, and this angle is 22 degrees. So what I'd like you to do is maybe pause the video and see if you can write the MUD, the magnitude, unit, direction, for each of these vectors. And you should be able to write it in 2 different ways. If you remember, write the direction both ways to see if you truly understand it. So go ahead and pause the video, and then I'm going to have the answers underneath each vector. Okay, so hopefully you were able to pause the video. And so for this first vector, we've got the 50-meter displacement vector, and we see that this angle is 50 degrees. So the way we would say the MUD for this, the magnitude is 50, the unit is meters, and the direction is 50 degrees east of south. Here is south, and it's east of that by 50 degrees. You could also conversely say it's 40 degrees south of east. For this vector, 3 meters per second squared, so that's the acceleration. So here's our magnitude, the unit, the direction is 31 degrees. Here's west, it's north of that by 31 degrees. So 31 degrees north of west, or 59 degrees west of north. You may have noticed by now that these angles, when you write both types of direction or both ways you could do it, they will always equal 90, right? Because you're just finding the other angle of that 90 degrees, and then you just flip the directions around. So east of south, south of east, north of west, west of north. For this vector, it's 14 degrees, so the magnitude's 5, the unit is meter, and the direction is 14 degrees north of west. Here's west, and it's north of that by 14 degrees. You could also say, use this angle, which is 76 degrees, and say 76 degrees west of north, right? Here's north, and it's west of that by 76 degrees. And finally, for this vector, the magnitude is 80. This is a 22-degree angle, so it's 22 degrees north of east, or 68 degrees east of north. Now, keep in mind, these vectors are not to scale. Like this 5-meter vector should be 10 times shorter than this 50-meter vector. Okay, I'm not drawing them to scale. So just know in real life, this vector would be 10 times longer than this vector, for example, because this number, the magnitude, is 10 times as great as this magnitude, okay? So in the next video, now that you know a little bit about how to draw vectors, we're going to start learning about how to use vectors in a math equation, and it'll be the first time in your life where you'll learn when there is a time where 2 plus 2 does not equal 4. And with that, I will bid you adieu, and always remember, PIP.